differential case overhaul, and ring gear replacement. If you are reusing the ring gear, the mounting location will need to be marked with a paint marker or a carbine tip scribe tool. The disadvantage to using paint is that it is possible that the paint will come off during the cleaning process. Carefully mount the case into the bench vise. Make sure to clamp on the flat side and not on the side gear. Test this by rotating the side gear with your finger. Loosen the ring gear bolts in a crisscross pattern. Use a 1/2 inch ratchet and a socket to loosen the bolts. The retaining clips will have locking tabs that will need to be bent out of the way before you can loosen the bolts. The locking tabs on this differential are all broken off from being removed multiple times. Choose the proper punch to remove the ring gear. Here I'm showing 3 different punches. This is a pin punch that is used for removing roll pins. This is a steel tapered punch, and this is a brass tapered punch. We will punch down through the bolt hole. This brass punch is too fat to fit the hole properly, so we need the smaller steel tapered punch. You can see it fits the hole better and easily strikes the ring gear. Wrap a rag around the vise to protect the gear teeth when the ring gear comes off. Use a hammer and punch in a crisscross pattern to remove the ring gear. Once the ring gear is separated from the case, it can be removed. This pinion pin holds the differential pinion gears to the case. The hole on the side of the case has a retaining pin that must be removed with a pin punch in order to remove the pinion pin. After clamping the case in the vise, use the pin punch and hammer to remove the retaining pin. Here you can see the retaining pin is being driven out by the punch. Reposition the case and use your finger or the brass drift punch to remove the differential pinion shaft. Before removing the spider and side gears, use a paint dot or carbine scribe tip to mark one side gear and one spider gear so they can be returned to the same location upon reassembly. Rotate the side gear to walk the spider gears to the large opening for removal. Now the side gears can be removed by pulling them straight out. Each side gear will have a spacer or calibrated thickness shim. The shim behind each side gear controls the side gear backlash, and both shims should have the same size. Sometimes compressed air is needed to free the shim from the oil adhesion that is causing it to stick to the side gear. Now the shim can be measured. I'm using a digital caliper. This shim measures 46 1/2 thousandths of an inch. Case reassembly. Lubricate the side gear and shim with differential oil and insert the side gear into the case. Repeat this with the second side gear, making sure to match the gear with the paint dot to the proper location. Select the pinion gear with the paint dot and place that on top, centered between the side gears. Place the second pinion gear centered between the side gears directly opposite the top pinion gear. To test that these gears are in perfect alignment, insert the pinion pin through the pinion gears. Rotate the pinion gears and pinion shaft until the shaft hits the case. Remove the shaft and continue to rotate the gears until the pinion gears align with the hole in the case. Be careful because the pinion gear thrust washer can fall out of location. If this happens, make sure to put it back before inserting the pinion pin. When inserting the pinion pin, make sure the hole in the shaft is in the proper position to insert the retention pin. Use the pin punch to ensure the alignment of the retention pin hole. Insert the pinion retention pin and use a hammer to tap it into position. Seat the pin to the bottom of the hole by using the hammer and a drift punch or pin punch. Notice that the pin is recessed in the hole. Finish the job by using a centering punch to peen or stake the hole. This makes it difficult for the retention pin to slide out during service. 4-pinion case assembly. Mark the two case halves in the pinion cross shaft with a paint marker or carbide scribe tool. Clamp the case in the bench vise and loosen the bolts that hold the two halves together in a crisscross pattern. Remove the bolts and tap on the case halves with a hammer to separate them. Inspect the top gear and the backlash shim and return it to the upper half of the case. Remove the cross shaft and pinion gears and perform a visual inspection. Place the cross shaft and pinion gears onto the side gear in the upper half. Remove the side gear and shim from the lower half and perform a visual inspection. Reverse these steps to reassemble and insert the side gear and shim into the lower half. Place the cross shaft and pinion gears onto the side gear and lower case half, making sure to align the paint markings. Place the upper half and upper side gear and shim onto the lower case half, making sure to align the paint markings. Get two of the bolts started and use a hammer to gently tap the two halves together. Install the rest of the case half bolts and snug them up in a crisscross pattern by hand or with a power tool. Use a torque wrench to tighten the case half bolts to specifications in a crisscross pattern. Ring gear installation. The ring gear needs to be heated to expand it for installation. I'm using a hot water solvent bath set to 190 degrees Fahrenheit. Once the ring gear is hot, remove it from the basket using heat-resistant gloves. Use compressed air to quickly evaporate any moisture from the ring gear and bolt holes. Locate the paint markings on the ring gear and on the case. Place the case over the ring gear and lift the ring gear into position on the case, aligning the bolt holes and paint markings. If the ring gear doesn't fully seat, you may need to tap it in place with a plastic-faced hammer. Once the gear is properly seated, install 2 bolts to hold it into position and snug them up by hand or with a power tool. Install the retaining plates and the rest of the bolts. Snug the rest of the bolts up by hand or with a power tool. The ring gear bolts are torqued in a 2-step procedure. First, torque the bolts 1/2 of the torque specifications in a crisscross pattern. Finally, perform the final torque at the full value in a crisscross pattern. If you have new lock plates, bend 2 of the locking tabs up against the flat side of each bolt head.